Hello, Algebra 1B students. You're looking at 4-5 practice writing a function rule from Mr. Fry's class. I want to take you through the odds. Let's get started. Write a function rule that represents each sentence. You can go ahead and pause this as I'm going to go through it rather quickly. Pause it when needed and then get back to it. Number one, 5 less than 1/4 of x is y. So I have 5 less than, but it has to be less than what? It has to be less than 1/4 of x. So I have to put my 1/4 of x out here. Is means equals y. 3, p is, so p is means equals 9 more than half of q. So I have half of q and 9 more than that. If you wrote the 9 first, 9 plus half of q, that would work also because addition is commutative. Number 5, 1.5 more than the quotient of a and 4 is b. So I have 1.5 more than the quotient of a and 4, or a divided by 4, that equals b. Once again, if you have these flipped, that's okay. It's commutative. Can't do that with subtraction and division, though. Can't flip them. Number 7, a babysitter's earnings, E, are a function of the number of hours N worked at a rate of $7.25 per hour. So $7.25 per the time, how many hours, number of hours, gives you E, the earnings. So that's how that one's going to look. Number 9, a plumber's fees are $75, F, are $75 for a house call. So no matter what, it's going to be 75 bucks, okay? And 60 per hour H. There's 60 per hour H for each hour work. So that's going to equal the fees. The fees, $60 per hour plus 75 just for showing up. Number 11, Jose is 3 years younger than 3 times his brother's age. Write a rule that represents Jose's age J as a function of his brother's age B. Okay, so 3 less than 3 times his brother's age, okay? And that's going to equal Jose's age. Now, if how old is Jose if his brother is 5? So you just put a 5 in here. 5 times 3 is 15 minus 3 is 12. So that's the second answer I have there. Number 13, write a function rule for the area of a rectangle whose length is 4 inches more than its width. So remember, we have length times width. Area equals length times width, okay? For a rectangle. What is the area of a rectangle when its width is 8 inches? So, you know, a good way to do that is to, you know, make sure you draw that. You could draw that and put these, you know, where they go. So the length is 4 inches. So we don't know anything about the length. So the length is 4 inches more than its width. So if I were to draw that, we don't know the width. So it's W. The length, I always go with the long is the length, is 4 inches more than the width. So it's, you know, W plus 4. So I actually have in here, you know, this becomes length times width. I have 2 widths here, you know. It's W plus 4 times W. So I use the distributive property. W times W gives me W squared, and W times 4 gives me 4W. So there's my formula, if you will. If you put 8 in here, you end up getting 96 inches. Okay, number 15, write a function rule for the area of a triangle. Remember, half base times width. Area equals half the base times the width. When with a base that's 2 meters less than 4 times its height. Half base times height is what I meant to say. Sorry about that. I'm still thinking of the last one. Half base times height. So it's 2 less than 4 times its height. That's my base. So this substitutes my b. So instead of a b here, I have another h here. So that's where it gets a little complicated. What is the area of the triangle when its height is 8 meters? So I plug in 8. I work it out on my calculator. Just type it in the way it looks. You get 120 meters squared. Now remember, the formula for a triangle area is the area equals half the base times the height. I don't put a b here because the b is telling me the base is 2 meters less than 4 times its height. So this is 2 less than 4 times the height. Okay, so that's why my b becomes 4h minus 2. All right, open-ended questions here. Describe a real-world situation that represents a nonlinear function. I'll be honest with you. I looked this up. I Googled it. So, some examples. Actually, from the book is the first one. The height of a soccer ball is a function of the time since it was kicked. I thought it was pretty interesting. This last one, the triangulation of GPS signals. That's a real-world representation of a nonlinear function. And any systems involving acceleration or deceleration. Okay. Situations involving acceleration or deceleration. So when you're comparing, like, car is accelerating ahead of another car or something like that, that's a nonlinear situation. It speeds up or it's slowing down. It's not going to be like a straight line function. Whereas when you get down to number 19, you have a straight line function here, and I'll get to that in a second. It says graph the ordered pair on the coordinate plane. So you have your x values, you have your y values. Just make a simple little graph like this. I went by ones here, and I have my x values by 1. I have my y values by 2, 2, 4, 6, 8, and you can see when I graph it, it makes a line. So this is a linear function. What I found out was that when you take your x, you multiply it by 2 and add 4 to it, you get your y. So take a look. When I 1 times 2, 2 times 1, plus 4 is 6. 2 times 2 plus 4 is 8. 3 times 2 plus 4 is 10, and so on. Okay, so that's my my equation. And is the equation a function? Yes, in fact, even better, it's a linear function because the points make a line. Okay, the points over here make a line. All right, hopefully that helps, and good luck with this assignment.